This is my space shooter game that I made in Unity. This is one of my older projects, and it's not perfect, but it's a fun little minigame to play, and I'm proud of how it turned out in the end. I programmed this game using C#. Allow me to open my script and show you how I made this game work. Okay, so here's my player script. Some of the most important parts of my minigame I have publicly referenced here at the top of my script are my enemies transform, my bomb game object that acts as my player's projectiles, and the transform from my bomb spawn point, attached just above my player, where the bomb appears and flies upward at the enemy's side of the screen when the player clicks the B key. I've also set up floats for my player's move speed, the player's max speed, the player's acceleration time, and deceleration time. My player moves left and right using the left and right arrow keys. If either key is held down, my player moves in that direction and starts speeding up the longer the key is held down. My acceleration is the player's maximum speed over their acceleration time, which is about half a second because max speed is 1 and acceleration time is 2, so that's 1 over 2, which is 0.5, so that's half a second. I made the player's acceleration as a float for smoother transition between speed values, and I made my velocity as a vector 3, so I could control the player's direction as well as their speed. Hence what I wrote here and here. So the player smoothly moves at their set move speed with acceleration being added onto it, with my use of mathf.min returning the player's accelerated speed. My player's transform position is updated to move thanks to the player's velocity being increased by the player's move speed, and while being forced in a specific direction. If the player releases their left or right arrow key, their speed is returned by mathf.max, right here, to be decreased by their current move speed minus their set max speed over deceleration time, multiplied by time.delta time for smoother frame-independent movement. I used mathf.max, so the player moves at a value greater than 0, but still at a slower speed than normal or when going faster. That's how it achieves that deceleration effect for move speed. And to prevent my player from zooming off screen, I added a little constraint on the spaceship's transform. If their position on the x-axis is greater than 9, or less than -9, their transform will set to stick to that number on the x-axis, and it will stay on that point until they move away from it. So if they keep moving left and they get to -9 on the x-axis, they can't go farther than that, and they'll stay in that spot until they move the other way. Same thing for +9 and going back this way. Under my bomb shoot void, if the player clicks the B key, they will shoot a bomb upward from their current position. The bomb speed is set to 7.5 multiplied by time.delta time for smooth frame-independent movement. And my bomb game object is instantiated at the bomb spawn point's position and rotation. And my bomb's isMain bool is set to be true. What does this bool mean, you ask? Well, so in my bomb script, I have my bomb's transform set up here, so I can translate the bomb's transform position after the player fires it. And I have my enemy transform referenced in here because I used it to find a game object tagged as an enemy. So when my bomb object collides with that object, the enemy is destroyed. I added colliders to the enemy spaceship and the bomb so they can collide with each other and call onTrigger enter 2D to destroy the enemy spaceship. Here's my code here. If collision.transform.compareTag enemy, that destroys the enemy game object. And I also instantiated an explosion cloud sprite just after the spaceship is destroyed for a fun little visual effect. I did that using a coroutine to instantiate the sprite at the enemy's death position for 1 second before being destroyed. For my bomb's movement, I made a float called bomb speed, which is the speed that my bomb moves at when fired. On update, I call my bomb movement function, which returns the bomb speed to the value I set it to, 7.5, and I translate the bomb's transform position upward at bomb speed. Not only can the player shoot bombs at the enemy, but they can also split them into multiple bombs by clicking the S key after firing a bomb. I made it so when S is clicked, another bomb is instantiated on the bomb's left and right sides. Now, finally getting to my bomb's bools, I made an isMain and a hasSplit bool, because I once found a slight problem with my code that lets the player split the bomb as many times as they want, making the bomb a broken mechanic. I made the isMain bool to track that the first singular bomb the player shoots is the main bomb that will be split. If the player splits the bomb, hasSplit becomes true, indicating that the bomb was split once. When my bomb is split into 3, the 2 left and right side bombs have their components with the isMain bool attached to them set to false. My logic that prevents the player from splitting bombs endlessly is that if the bomb shot is the singular main bomb being shot and it hasn't split yet, the player can click S to split it. So hasSplit becomes true, and my non-split function is called and isMain returns false for the new bombs. The player can't split the bombs twice if isMain is false. They'll have to click B again to shoot another bomb to be able to turn one bomb into 3 again. In other words, clicking the B key again will set isMain for the bomb true again. So this can work here. It's kind of like the bluebird from Angry Birds that splits into 3 birds. Now let's take a look at how I programmed my enemy. Okay, so here's my enemy script. My enemy moves left and right on the top half of the screen. How I made this work is by making a move speed float that my enemy moves at, and I also made 2 positions for the enemy to go back and forth between. I made a vector 3 called target, and when my game starts, my target vector is equal to enemy max right position, meaning that enemy max right position will be the first spot that my enemy will move to. Here in my enemy movement function that I have called an update, I have my enemy max left and enemy max right transforms referenced, so my function here can use them. My enemy's transform position is equal to vector 3 dot move towards the target right here at move speed. So if my enemy's transform position is equal to enemy max right dot position, target is reset to enemy max left dot position. And if my enemy reaches enemy max left dot position, the target is reset to enemy max right again. That's how I got my enemy going back and forth. So let me go back into Unity and show you my game objects here. So here's enemy max left. It's just a blank game object with just a transform. Right here is how far my enemy moves to the left without having to go off screen. Same thing with enemy max right here. So yeah, it's kind of like my player's constrained movement from side to side, only my enemy moves between 2 public transforms of game objects instead of moving to one spot to another hard-coded. These are public positions and transforms. So my enemy attacks the player by shooting missiles. Back at the top of my script, I have my enemy's missile spawn point transform, and this is my missile prefab game object that will be instantiated when the missile is shot by the enemy. So when my game starts, my enemy's coroutine for shooting missiles starts. Until my enemy is destroyed, it'll just keep shooting missiles every 2.5 seconds. So while my enemy is still active, the activity for my shoot missile enumerator remains true. If the player is still alive, this is why I wrote if player transform is not null, my missile speed is returned to a value of 9, and my missile game object is instantiated at my missile spawn point. At missile spawn point position and rotation. Now let's take a look at the functionality for my enemy's missile. Here's my missile script. On start, I have my target for my missile to fly towards set as my player's transform position, and I set my missile's direction vector to be a normalized value of the distance from my player's current position and my missile's position. My missile's rigid body velocity is equal to missile direction multiplied by my missile speed. I use mathf.atan2 to calculate the missile's rotation before the missile is launched, so it flies downward and at the correct angle towards where the player was just at, when the coroutine for my enemy's shoot missile enumerator finishes waiting to instantiate the missile. My missile flies downward at missile speed, and just like for what I did to my enemy in my bomb script, my tagged player object is destroyed on collision, and the explosion sprite is instantiated at the player's death position. That's all the code I have to show for this game. Now, let's see it in action. Time for the moment we've all been waiting for. Let's see my game in action. So my player can move left and right with the arrow keys. My enemy is shooting a missile. Shooting missiles right at me. Gonna fire a bomb and split it. Oh, just dodged that one. Got him. So that's it. Thanks for watching.